Every night, you lose your mind. This is not a metaphor. Every night, as you slip from wakefulness into sleep, the most sophisticated information processing system in the known universe, your brain systematically shuts down the very faculties that make you a rational, reality-testing, critically thinking human being. Your prefrontal cortex, the region responsible for logic, judgment, planning, and the ability to distinguish real from imaginary, goes largely offline. Your dorsolateral prefrontal cortex, the seat of working memory and executive control, reduces its activity to a whisper. The neurochemical environment of your brain shifts dramatically. Serotonin and norepinephrine, the neurotransmitters that maintain waking alertness and focused attention, drop to near zero. And in this neurochemically altered, critically impaired, logically defenseless state, your brain does something extraordinary. It generates an entire world. Not a vague impression, not a hazy feeling, a world, with spatial dimensions, with visual detail, with characters who speak and act and have apparent motivations, with narratives that unfold across time, with emotional textures that can be as intense as anything in waking life and sometimes more so. You walk through buildings that your brain constructs in real time. You have conversations with people who do not exist, and you believe every word they say. You experience fear, joy, grief, desire, and wonder with your full emotional apparatus engaged. And at no point during the experience do you question its reality. The dream is, for the duration that you are inside it, the most convincing reality you have ever experienced. And then you wake up and dismiss it as nothing. This is one of the most remarkable phenomena in all of biology, and it is one of the least understood. After more than a century of scientific investigation, after decades of brain imaging, sleep laboratory research, and neurochemical analysis, the fundamental question about dreams remains unanswered. What are they for? Why does the brain, which is under intense evolutionary pressure to conserve energy and optimize survival, spend roughly 2 hours of every night constructing elaborate, immersive, emotionally charged virtual realities that the dreamer almost never remembers and that appear to have no practical function? The history of science's attempts to answer this question is a history of partial successes and fundamental failures, and the failures are as instructive as the successes, because they reveal the limits of the materialist framework when applied to the most intimate and most mysterious product of the human mind. The modern scientific study of dreams begins in 1953, in the sleep laboratory of Nathaniel Kleitman at the University of Chicago. Kleitman's graduate student, Eugene Asarinsky, was monitoring the eye movements of sleeping infants when he noticed something unexpected. At regular intervals during sleep, the infants' eyes began moving rapidly beneath their closed lids. The movements were not random twitches, they were coordinated, purposeful-looking, as if the sleeping infants were watching something. Asarinsky and Kleitman investigated further, extending their observations to adult subjects, and discovered that these periods of rapid eye movement, which they named REM sleep, occurred in regular cycles throughout the night, approximately every 90 minutes, and were strongly correlated with dream reports. When subjects were awakened during REM periods, they reported vivid, detailed, narrative dreams, approximately 80% of the time. When awakened during non-REM periods, they rarely reported dreams, and when they did, the dreams were fragmentary and thought-like rather than vivid and immersive. This discovery transformed sleep research. It provided for the first time an objective, physiological marker for dreaming. You could now study dreams not by relying on unreliable morning recollections, but by monitoring brain activity in real time and waking subjects at the precise moment that dreams were occurring. The sleep laboratory became a window into the dreaming mind, and what it revealed was both fascinating and deeply puzzling. During REM sleep, the brain is almost as active as it is during waking. The EEG patterns of REM sleep are virtually indistinguishable from those of alert wakefulness, fast, desynchronized, low-amplitude oscillations that indicate intense neural processing. The visual cortex is highly active, generating the vivid imagery that characterizes dream experience. The limbic system, the emotional core of the brain, including the amygdala and the hippocampus, is more active during REM sleep than during waking, which explains the intense emotional quality of dreams. The motor cortex generates movement commands, which is why dreaming often involves the experience of walking, running, flying, and other physical activities. But the signals from the motor cortex are intercepted at the brainstem and prevented from reaching the muscles, producing a state of temporary paralysis called REM atonia that keeps the sleeping body motionless while the dreaming mind races through its constructed world. There is a further remarkable feature of REM sleep that is often overlooked. The brain generates its own time during dreaming. In waking life, your experience of duration is calibrated to external events, the ticking of a clock, the movement of the sun, the rhythm of your heartbeat. In dreaming, there is no external calibration. The brain generates its own temporal framework, and that framework is not bound by the same rules that govern waking time. Dreams can compress hours of narrative experience into minutes of clock time. Conversely, brief REM periods can feel like they contain extended, detailed experiences. The temporal structure of the dream is determined by the dreaming brain, not by the external world. The dreamer lives in a time that the brain creates. This is directly relevant to our investigation because it demonstrates that the brain's experience of time is, even in normal sleep, decoupled from physical time. The dream is a state in which subjective time and objective time diverge, in which the brain's internal time generation machinery operates independently of the external temporal markers that normally constrain it. If the brain can create its own time during dreaming, the question arises, can it also create its own temporal direction? Can the dreaming brain move forward and backward along the temporal axis with a freedom that the waking brain does not possess? The brain during REM sleep is, in almost every measurable respect, awake. It is processing information at waking levels of intensity. It is generating sensory experiences with waking levels of vividness. It is producing emotional responses with waking levels of intensity, and sometimes greater. The only things that are different are the source of the input and the absence of critical evaluation. During waking, the brain processes information from the external world through the senses. During dreaming, the brain processes information that it generates internally. And during waking, the prefrontal cortex evaluates incoming information for plausibility and coherence. During dreaming, the prefrontal cortex is largely silent, and the brain accepts its own creations as unquestionable reality. The first major scientific theory of dreaming arrived in 1977, when the Harvard psychiatrists J. Allen Hobson and Robert McCarley published their activation synthesis model. Hobson and McCarley proposed that dreams are essentially meaningless, the brain's attempt to make narrative sense out of random neural noise. During REM sleep, they argued, the brainstem sends random activation signals to the cortex. The cortex, doing what it always does, tries to organize these random signals into a coherent story. The result is a dream, a narrative that feels meaningful but is actually a post hoc rationalization of random neural firing. Dreams, in this view, are not messages from the unconscious, not windows into hidden truths, not anything of psychological or spiritual significance. They are neural garbage, the brain's screensaver, running in the background while the real work of sleep, physical restoration, and memory consolidation takes place. The activation synthesis model dominated dream science for 2 decades, and it still influences popular understanding of dreams. But it has been progressively undermined by evidence that it cannot accommodate. The first problem is that dreams are not random. If dreams were the cortex's attempt to narrativize random brainstem signals, you would expect dream content to be incoherent, disjointed, and devoid of meaningful pattern. But systematic analysis of dream content conducted by researchers including Calvin Hall, Robert van der Castle, and G. William Domhoff, using databases of thousands of dream reports, has shown that dreams are remarkably consistent and structured. The same dreamer tends to dream about the same themes, the same settings, the same characters, and the same emotional situations, night after night, year after year. Dream content reflects the dreamer's waking concerns, relationships, and preoccupations with a specificity that random activation cannot explain. If the activation were truly random, the content should be random too. It is not. The second problem is that dreaming is not limited to REM sleep. The original Aserinsky-Kleitman discovery linked dreaming to REM, and for decades REM sleep and dreaming were treated as synonymous. But subsequent research has shown that dreams also occur during non-REM sleep, including the deep, slow-wave stages of sleep that are as far from REM as the sleep cycle gets. The neurologist Mark Solms, working at the Royal London Hospital, studied patients with brain lesions that selectively eliminated either REM sleep or dreaming, and he made a crucial discovery. The two could be dissociated. Patients with brainstem lesions that eliminated REM sleep could still dream. Patients with forebrain lesions that eliminated dreaming could still enter REM sleep. Dreaming and REM sleep are correlated but not identical. They are produced by different neural mechanisms, and one can exist without the other. Solms's work identified the brain region most critical for dreaming, not the brainstem, as Hobson and Macaulay had assumed, but the ventromedial prefrontal cortex and the temporoparieto-occipital junction regions associated with desire, motivation, spatial imagery, and the construction of virtual reality simulations. Dreaming, Solms argued, is not the cortex passively reacting to random brainstem noise. It is the forebrain actively generating a motivated, purposeful, internally driven simulation of reality. The dream is not an accident. It is an achievement, a sophisticated product of the brain's most advanced simulation machinery. The Finnish cognitive neuroscientist Antti Revonsuo proposed an alternative framework in 2000 that took the purposefulness of dreams seriously. His threat simulation theory argues that dreaming evolved as a biological mechanism for rehearsing responses to dangerous situations. The dreaming brain constructs realistic simulations of threatening scenarios: being chased, falling, being attacked, losing a loved one, and allows the dreamer to practice their responses in a safe, consequence-free virtual environment. The emotional intensity of dreams is not a bug. It is the feature that makes the simulation useful. By generating genuine fear, grief, and urgency, the dream trains the brain's emotional response systems for real-world threats. Revonsuo's theory is supported by content analysis showing that threat-related themes are disproportionately common in dreams, but it does not explain all dream content. It does not explain why dreams frequently involve positive experiences, creative insights, sexual encounters, absurd scenarios, and elaborate narrative structures that have no obvious connection to threat rehearsal. And it does not explain the most striking feature of many dreams, their apparent knowledge of things the dreamer does not consciously know. The psychologist Carl Jung, whose framework predated the neuroscience by decades but has proven remarkably compatible with modern findings, proposed that dreams are the psyche's attempt to compensate for the one-sidedness of waking consciousness. If your waking life is too focused on logic, your dreams will be emotional. If your waking life is dominated by fear, your dreams will offer courage. The dream, in Jung's framework, is not random noise and not mere threat rehearsal. It is the psyche's self-correcting mechanism, a process that maintains psychological balance by presenting the conscious mind with precisely the material it most needs to integrate. This compensatory function, Jung argued, explains why dreams so often feel meaningful because they are meaningful. They are the voice of the parts of the mind that waking consciousness has excluded, presenting their case in the only forum available, the dream. The third problem for the activation synthesis model is the existence of lucid dreams. A lucid dream is a dream in which the dreamer becomes aware that they are dreaming aware within the dream, that the world they are experiencing is a construction of their own mind. The phenomenon was documented anecdotally for centuries, but it was not scientifically verified until 1975, when Keith Hearn at the University of Hull and, independently, Stephen LaBerge at Stanford University demonstrated that lucid dreamers could signal from within their dreams to researchers monitoring them in the sleep laboratory. The method was ingenious. Since the eye muscles are not paralyzed during REM sleep, lucid dreamers were instructed to move their eyes in a pre-agreed pattern, left-right, left-right, when they became lucid within a dream. The eye movements were clearly visible on the polysomnographic recording, providing objective real-time proof that the subject was simultaneously dreaming and aware of dreaming. LaBerge's work at Stanford opened an entirely new field of dream research. He showed that lucid dreamers could perform predetermined tasks within their dreams, counting, singing, performing motor sequences, and that these tasks produced measurable brain activity patterns that corresponded to the same tasks performed while awake. When a lucid dreamer sang a song in the dream, the same brain regions activated as when they sang the song while awake. When they clenched their fist in the dream, the motor cortex fired in the same pattern as during waking fist clenching. The dream world, for the brain, was neurologically indistinguishable from the waking world. The simulation was perfect. In 2021, a landmark study published in Current Biology by Karen Konkerly and colleagues at Northwestern University took this further. They established real-time, two-way communication with lucid dreamers. The researchers asked mathematical questions such as, "What is 8 minus 6?" to sleeping subjects through earphones, and the lucid dreamers, from within their dreams, answered correctly by moving their eyes the corresponding number of times. 8 minus 6 equals 2, two eye movements. The dreamers were performing arithmetic in real time while asleep and dreaming, and communicating the answers to researchers in the waking world. The Northwestern experiment was replicated and extended by teams in France, Germany, and the Netherlands, all of whom reported similar results. Lucid dreamers were able to respond to questions, follow instructions, and perform cognitive tasks that required real-time processing of novel information from the external world. The boundary between the dreaming mind and the waking world was not impermeable. It was porous. Information could flow both directions from the external world into the dream, and from the dream back to the external world, through the medium of voluntary eye movements and facial muscle signals. This porosity has profound implications. If the dreaming mind can receive and process information from the external physical world, the question of what other information sources it might access becomes legitimate. The waking brain receives information through the 5 senses. The dreaming brain receives information through internal generation and, as the lucid dreaming experiments show, through limited external channels. But are there other channels? Are there information sources that the dreaming brain can access that the waking brain cannot? This is the question that the anomalous evidence forces us to confront. Consider what this means. The dreaming brain is not merely replaying stored information or processing random noise. It is capable of receiving new information from the external world, processing it, solving novel problems, and communicating the solutions, all while maintaining an immersive, internally generated virtual reality. The dream is not a passive byproduct of sleep. It is an active, intelligent, responsive state of consciousness that has capabilities the waking mind does not always access. The neuroscience of dreaming has revealed one more fact that is critical for our investigation. The brain during dreaming is operating in a mode that is, in several important respects, more connected and more integrated than the waking brain. The neuroscientist Giulio Tononi, whose integrated information theory we have encountered throughout this series, has studied the information dynamics of the sleeping brain using high-density EEG and transcranial magnetic stimulation. His research has shown that during deep sleep, the brain's connectivity breaks down different regions, process information independently, and the integrated, whole-brain communication that characterizes waking consciousness is disrupted. This is why deep sleep is unconscious. The brain's integration collapses, and with it, phi, the mathematical measure of consciousness, drops to near zero. But during REM sleep, something different happens. Connectivity does not collapse. In many ways, it increases. The default mode network, the brain's autobiographical, narrative, self-referential system, becomes highly active and highly connected to other networks, including the limbic system, the visual cortex, and the memory systems of the hippocampus. Brain regions that normally operate independently during waking begin to communicate in unusual patterns, forming novel connections that do not exist in the waking state. The dreaming brain is not less integrated than the waking brain. It is differently integrated, connected in ways that waking consciousness does not permit. This increased connectivity during dreaming has been linked to creativity, insight, and problem-solving. The chemist Auguste Kekulé famously discovered the ring structure of benzene after dreaming of a snake eating its own tail. The mathematician Srinivasa Ramanujan attributed many of his most important theorems to dreams in which the Hindu goddess Namagiri presented them to him. Paul McCartney heard the melody of Yesterday complete in a dream and woke up to write it down. Otto Loewi, who won the Nobel Prize for his discovery of chemical neurotransmission, designed the experiment that proved his theory in a dream. Elias Howe solved the problem of the lock-stitch sewing machine after dreaming of spears with holes in their tips. These anecdotes are often dismissed as colourful but unscientific, but controlled studies have confirmed the effect. A 2004 study by Ulrich Wagner and colleagues at the University of Lübeck presented subjects with mathematical puzzles that had a hidden shortcut. Subjects who slept between training and testing were nearly 3 times more likely to discover the shortcut than subjects who stayed awake for the same period. Sleep, and specifically REM sleep, when dreams occur, did not merely consolidate the memory of the puzzle, it restructured the representation, revealing a pattern that was invisible during waking analysis. The dreaming brain found something that the waking brain could not. The neuroscientist Matthew Walker, in his influential book Why We Sleep, describes dreaming as the brain's nocturnal therapist and creative incubator. During REM sleep, Walker argues, the brain replays emotional memories in an altered neurochemical context. Specifically, in the absence of norepinephrine, the stress-related neurotransmitter that is normally present during waking recollection. This allows the emotional charge of the memory to be processed and reduced without the physiological stress response that accompanies waking recall. The dream strips the emotion from the memory, preserving the information while discarding the pain. This is why, Walker argues, time heals all wounds. The healing happens during sleep, in the dreams you do not remember. There is one more feature of dream neuroscience that demands attention. The hippocampus, the brain's primary memory consolidation system, is highly active during REM sleep. During waking, the hippocampus encodes new experiences into short-term memory. During REM sleep, it replays those experiences and transfers them to long-term storage in the cortex. This process, called memory consolidation, is one of the best established functions of sleep. But the hippocampal replay during REM is not a faithful recording. It is creative. The hippocampus does not simply replay the day's events in order. It recombines them, mixes them with older memories, and generates novel combinations that never occurred in waking life. The dream is the experiential surface of this recombinatory process, the subjective experience of the hippocampus remixing reality. This recombinatory function may explain the creative breakthroughs that occur in dreams. By combining information from different sources, different time periods, and different contexts, the dreaming brain can discover connections and patterns that the more constrained waking brain misses. But it raises a deeper question. If the hippocampus is recombining information during dreaming, what information is available for recombination? Only the day's experiences and stored memories? Or could there be other sources of information, sources that the waking brain's sensory gating mechanisms normally exclude, but that become accessible when those mechanisms are relaxed during sleep? But none of this explains the most disturbing and most scientifically resistant feature of dreams, their occasional, well-documented, and completely inexplicable capacity to anticipate the future. In 1927, the British aeronautical engineer J.W. Dunn published a book called An Experiment with Time that caused a sensation in both the scientific and literary worlds. Dunn had noticed, over a period of years, that his dreams frequently contained elements that corresponded not to past events but to future ones. Events that had not yet occurred at the time of the dream, but that transpired, sometimes in precise detail, in the days following the dream. He described dreaming of a volcanic eruption and the specific headline of a newspaper reporting it before the event occurred. He described dreaming of details of places he had never visited but would visit in the coming weeks. Dunn did not attribute these experiences to supernatural causes. He was an engineer, trained in the scientific method, and he approached the phenomenon with characteristic rigor. He proposed a theory of serial time, a model in which time has multiple dimensions, and the dreaming mind, freed from the constraints of waking temporal perception, can access information from different temporal locations. During waking, consciousness is fixed to the present moment, moving forward along one temporal dimension. During dreaming, the constraints loosen, and consciousness can drift across the temporal landscape, picking up information from the future as easily as from the past. Dunn's work was influential. It impressed the playwright J.B. Priestley and the novelist J.R.R. Tolkien, among others, but it was dismissed by mainstream science as anecdotal and subjective. The problem with precognitive dream reports is the same problem that plagues all anecdotal evidence: selective memory, confirmation bias, and the tendency to remember hits and forget misses. If you dream about 100 things and one of them comes true, you remember the one and forget the 99. This is a legitimate criticism, and it applies to the vast majority of precognitive dream reports, but not to all of them. In 2011, the psychologist Darrell Bem at Cornell University published a paper in the Journal of Personality and Social Psychology, one of the most prestigious journals in psychology, reporting results from 9 experiments involving over 1,000 subjects that appeared to demonstrate retroactive influence of future events on present behavior. In one experiment, subjects were shown a list of words and later given a surprise recall test. After the test, they practiced a random subset of the words. The remarkable finding was that subjects recalled the words they would later practice better than the words they would not, as if the future practice session reached backward in time and influenced the present memory. Performance. Bem called this feeling the future, and it was published after passing the same rigorous peer review that every other paper in the journal undergoes. The publication caused a firestorm. Replication attempts produced mixed results. Some laboratories found similar effects, others did not, A large-scale replication effort coordinated by the psychologist Jeff Gallach found no significant effect. But a meta-analysis conducted by Bem himself, along with Patrizio Tresoldi and Jessica Utz, published in 2015, pooled the data from 90 experiments conducted by 33 laboratories in 14 countries and found a small but statistically significant overall effect. The probability that the pooled result was due to chance was less than 1 in a billion. We have encountered this pattern before in our investigation of the evil eye, a small but persistent effect, statistically significant across large datasets, inconsistent in individual replications, no known mechanism, and dismissed by mainstream science not because the data is flawed but because the implications are unacceptable. The most extensive controlled study of precognitive dreaming was conducted at the Maimonides Medical Center in Brooklyn in the 1960s and 1970s by Montague Ullman and Stanley Krippner. In their experiments, a sleeping subject in a soundproofed room was monitored by EEG. When the subject entered REM sleep, a researcher in a distant room concentrated on a randomly selected target image, a painting, a photograph, or an illustration. The sleeping subject was then awakened and asked to describe their dream. Independent judges, blind to the target identity, evaluated the correspondence between the dream reports and the target images. Over the course of more than 100 formal sessions, the Maimonides experiments produced statistically significant results. Dream reports corresponded to target images at rates that exceeded chance, sometimes dramatically. In the most celebrated session, the target image was Salvador Dali's painting, The Last Supper. The dreaming subject reported a dream about a group of people sitting at a long table, eating a meal, in a room with unusual lighting and a feeling of religious significance. The correspondence was judged highly significant by the blinded evaluators. The Maimonides experiments were not without methodological criticisms. The judging procedure, the randomization of targets, and the potential for sensory leakage were all debated. But the experiments were conducted over more than a decade, published in peer-reviewed journals, and have never been convincingly explained by any conventional mechanism. Ullman and Krippner did not claim to have proven dream telepathy or precognition. They claimed to have produced data that warranted further investigation. That further investigation has largely not been pursued, not because the data was refuted, but because the scientific community chose not to follow it. The historical record of precognitive dreams extends far beyond anecdote. Abraham Lincoln reportedly dreamed of his own assassination days before it occurred, describing to his wife and several associates a dream in which he wandered through the White House and found a corpse lying in state, surrounded by mourners. When he asked who had died, a soldier told him, "The president. He was killed by an assassin." Mark Twain dreamed of his brother Henry lying in a metal coffin with a bouquet of white flowers and a single red rose on his chest. Weeks later, Henry was killed in a steamboat explosion, and Twain arrived at the funeral to find the scene exactly as he had dreamed it, down to the metal coffin and the single red rose that a woman had placed on Henry's chest moments before Twain arrived. These cases are anecdotal. They cannot be verified to the standards of controlled experiments, but they are documented by credible witnesses and are consistent with the pattern observed in the Maimonides experiments. The dreaming mind appears, in certain cases, to access information that is not available through ordinary sensory or memorial channels. Whether this information comes from the future, from other minds, or from some other source that our current framework cannot describe is the question that remains open. What are we to make of all this? The neuroscience tells us that dreaming is not random noise. It is a sophisticated, purposeful, neurologically active state in which the brain generates immersive simulations, solves problems, processes emotions, and forms novel connections that waking consciousness cannot produce. The anomalous evidence Dunn's precognitive dreams, Bem's retroactive influence experiments, the Maimonides telepathy studies suggests, controversially but persistently, that dreaming may involve access to information that is not available through ordinary sensory channels or ordinary temporal sequence. And here is where the contemplative traditions enter, not as competitors to the science, but as frameworks that have been taking dreams seriously for far longer than science has existed, and that offer a perspective on dreaming that the materialist framework cannot accommodate. In Islam, the Prophet Muhammad stated that the true dream, al-ruya al-sadiqa, is 1/46th part of prophethood. This is not a casual remark. It is a precise theological statement that places dreaming in direct continuity with divine revelation. Prophethood is the reception of knowledge from the divine realm. The true dream is a fraction of that same process, a channel through which information from beyond the ordinary sensory world reaches human consciousness. The Prophet distinguished between three types of dreams: the true dream, which comes from God; the disturbing dream, which comes from the ego's fears and desires; and the confused dream, which is neural noise. The Islamic tradition does not claim that all dreams are meaningful. It claims that some dreams are, and that distinguishing between them is one of the subtlest and most important skills a human being can develop. The Quran devotes an entire surah, Surah Yusuf, the 12th chapter, to the story of the Prophet Joseph, whose ability to interpret dreams is presented as a divinely granted gift. Joseph interprets the dreams of his fellow prisoners, correctly predicting that one will be freed and the other executed. He interprets the Pharaoh's dream of 7 fat cows, followed by 7 thin cows, correctly predicting 7 years of abundance, followed by 7 years of famine. The dreams are not symbolic in the Freudian sense, disguised wishes from the unconscious. They are informational in the most direct sense, previews of future events, transmitted through the dream channel, requiring skilled interpretation to decode, but containing genuine, actionable knowledge about what has not yet happened. In the Hindu tradition, the Mandukya Upanishad identifies dreaming as one of the 4 fundamental states of consciousness: waking, dreaming, deep sleep, and turiya. This is not a hierarchy in which waking is real and dreaming is false. It is a map of consciousness in which each state reveals a different aspect of reality. Waking consciousness apprehends the gross, material world. Dreaming consciousness apprehends the subtle world, a realm of forms and experiences that is real in its own right, governed by its own laws, and accessible only when the constraints of waking perception are relaxed. The dream world, in the Mandukya's framework, is not less real than the waking world. It is differently real, a dimension of experience that the waking mind cannot access, not because it does not exist, but because the waking mind's filters are too tight to let it through. In the next stage of this investigation, we will explore the quantum mechanical framework that may explain how dreams could access information from beyond the ordinary sensory channels. Because if the many worlds interpretation of quantum mechanics is correct, if every quantum event branches reality into multiple coexisting timelines, each one as real as the others, then the question is not whether alternative realities exist. They do. The question is whether consciousness, in the altered state of dreaming, can briefly access them. And the physics, as we will see, does not rule this out. It may even require it. The dream is not nothing. It is not noise. It is not the brain's screensaver. It is something else, entirely. Something that science is only beginning to understand, and that the contemplative traditions have been mapping for millennia. What that something is may depend on what consciousness is, and what consciousness does when the waking filters are removed, and it is left, for a few hours each night, to wander freely through the landscape of possibility. We have established that dreaming is not noise. It is not the brain's screensaver. It is an active, sophisticated, neurologically intense state of consciousness in which the brain generates immersive simulations, solves problems it cannot solve while awake, processes emotions in a unique neurochemical environment, and according to a persistent body of anomalous but statistically significant evidence, occasionally accesses information that is not available through any known sensory channel. The neuroscience cannot explain this last feature, neither can any conventional theory of mind. But there is a framework in physics that can at least accommodate it, a framework so radical in its implications that most physicists who accept it still hesitate to follow it to its logical conclusion. That framework is the many worlds interpretation of quantum mechanics, and its implications for the nature of dreaming are as extraordinary as anything we have encountered in this series. The many worlds interpretation begins with a simple question that has haunted physics since the 1920s. What happens when a quantum measurement is made? In the standard Copenhagen interpretation, a quantum system exists in a superposition of all possible states until a measurement collapses the superposition into one definite outcome. Before you measure an electron's spin, it is simultaneously spin up and spin down. After you measure it, it is one or the other. The measurement selects one outcome and eliminates all the others. This is clean, simple, and mathematically effective. But it has a problem that has never been resolved. What causes the collapse? What is special about measurement? Where in the chain of physical interactions does the superposition end and the definite outcome begin? The Copenhagen interpretation has no answer. It simply postulates that collapse happens and moves on. In 1957, a Princeton graduate student named Hugh Everett III proposed a solution that was so radical that it nearly destroyed his career. Everett argued that the collapse never happens. The superposition never resolves. When a measurement is made, the measuring apparatus, the observer, and the entire universe enter the superposition, along with the quantum system. The universe splits. In one branch, the electron is spin up and the observer sees spin up. In another branch, the electron is spin down and the observer sees spin down. Both outcomes occur. Both branches are equally real, and the observer in each branch has no access to the other branch, no way of knowing that the split occurred, no way of detecting the other version of themselves who saw the other outcome. Everett's thesis advisor was John Archibald Wheeler, the same Wheeler whose participatory universe and it from bit we encountered in our investigation of the first observer. Wheeler recognized the brilliance of Everett's idea, but also recognized how poorly it would be received. He was right. The physics community largely ignored Everett's work for decades. Everett left academia, went into defense research, and died in 1982 without seeing his interpretation gain wide acceptance. But acceptance came. By the late 20th century, the many worlds interpretation had become one of the leading interpretations of quantum mechanics, endorsed by a significant fraction of theoretical physicists, including David Deutsch, Sean Carroll, Max Tegmark, and many of the researchers working on quantum computing and quantum information theory. The reason for its revival was not philosophical, it was technical. Many worlds is the simplest interpretation of quantum mechanics in a precise mathematical sense. It adds nothing to the equations. It simply takes the Schrödinger equation at face value and follows it wherever it leads. The Schrödinger equation does not contain a collapse mechanism. It describes a universal wave function that evolves smoothly and deterministically, never collapsing, never selecting one outcome over another. Many worlds is what quantum mechanics looks like if you believe the equations and refuse to add anything to them. The physicist David Deutsch at the University of Oxford has provided what many consider the most compelling argument for many worlds: quantum computing. A quantum computer performs calculations by exploiting superposition, by processing all possible inputs simultaneously and combining the results. Deutsch argues that this computational power cannot be explained unless the parallel computations are actually happening somewhere. If the other branches of the superposition are not real, if they are merely mathematical abstractions, then where is the computation being performed? The quantum computer produces correct answers that require exponentially more computational resources than any classical computer possesses. Those resources must come from somewhere. Deutsch's answer: they come from the other branches of the multiverse. The quantum computer works because it literally computes across parallel realities. Deutsch's argument is not philosophical hand-waving. It is a concrete, testable, engineering-level claim. Quantum computers exist. They perform calculations that no classical computer can replicate in any reasonable time. Shor's algorithm, running on a sufficiently large quantum computer, can factor large numbers exponentially faster than any classical algorithm. The computational resources required for this factoring exceed the resources available in the entire observable universe, if only classical physics were true. The quantum computer accomplishes it by, in Deutsch's framework, distributing the computation across the parallel branches of the multiverse. The other branches are not theoretical curiosities. They are computational resources that quantum computers are already using. The multiverse is not a speculation. It is an engineering requirement. Sean Carroll, a physicist at Johns Hopkins University and one of the most articulate advocates of many worlds, has argued that the interpretation is not merely one option among several. It is the default position, the interpretation that requires the fewest additional assumptions, and that takes the mathematics of quantum mechanics most seriously. Carroll acknowledges that many worlds seems extravagant, an infinity of branching universes is a high ontological price to pay. But he argues that the alternatives are worse. They require adding collapse mechanisms, observer-dependent physics, or hidden variables that are not present in the equations and that have never been experimentally detected. Many worlds is expensive in terms of ontology. It is cheap in terms of physics, and in science, Carroll argues, the physics should win. Now, if many worlds is correct, the implications for our investigation are staggering. At every quantum event, and quantum events occur trillions of times per second in every atom of your body, the universe branches. In some branches, the event has one outcome. In other branches, it has another. Every possible outcome of every quantum event is realized in some branch of the multiverse. This means that there are branches in which every possible version of your life has occurred. There are branches in which you chose differently at every decision point. There are branches in which the coin landed on the other side, the job went to someone else, the relationship lasted or ended differently. Every possibility is actual, somewhere in the multiverse. The branches are real. They are not hypothetical. They are not metaphorical. If many worlds is correct, they are as physically real as the branch you currently inhabit. The other versions of you are not imaginary. They are you, equally conscious, equally real, equally convinced that their branch is the only one. But here is the crucial question for our investigation. Are the branches completely isolated? Can no information pass between them? Is the boundary between one branch and another an absolute, impermeable wall? The standard answer is yes. Decoherence, the process by which quantum superpositions lose their coherence through interaction with the environment, ensures that the branches diverge rapidly and irreversibly. Once a quantum event has decohered, the different branches become, for all practical purposes, independent realities with no causal connection. The other branches exist, but you can never access them, detect them, or be affected by them. They are as real as your own branch, and as unreachable as a parallel universe on the other side of an event horizon. But, for all practical purposes, is not the same as in principle. And several physicists have noted that the decoherence barrier, while extraordinarily effective in macroscopic systems, may not be absolutely impermeable. The physicist David Deutsch himself has noted that decoherence is a matter of degree, not of kind. A system that is strongly decohered is effectively isolated from other branches. A system that is weakly decohered retains some quantum coherence, some residual connection to the other branches, some faint trace of the superposition that has not yet been completely resolved. In most macroscopic situations, the decoherence is so complete that the residual coherence is unmeasurably small. But in certain special conditions, conditions of extreme isolation from the thermal environment, conditions of reduced sensory input, conditions in which the normal channels of decoherence are partially closed, the residual coherence might be large enough to have detectable effects. Now consider what happens to the brain during sleep. During waking, the brain is in constant interaction with the external environment through the senses. Photons hit the retina, sound waves vibrate the eardrums, chemical molecules stimulate the olfactory receptors, tactile signals flow from the skin. This massive influx of environmental information is a powerful source of decoherence. It constantly collapses the brain's quantum states into definite, classical configurations. The waking brain is, from a quantum mechanical perspective, maximally decohered, maximally locked into one branch of the multiverse by the relentless measurement performed by the sensory environment. During sleep, this changes dramatically. The thalamic gate closes. Sensory input is reduced to a trickle. The brain is no longer being constantly measured by the external environment. The decoherence rate drops. Not to zero, the brain is still a warm, wet system with enormous internal thermal noise. But the external component of decoherence, the component driven by sensory interaction with the environment, is drastically reduced. The reduction of external decoherence during sleep is not merely theoretical, it is measurable. Studies using magnetoencephalography have shown that the brain's electromagnetic environment changes significantly during sleep. The constant bombardment of sensory-evoked potentials that characterizes the waking state ceases almost entirely. The thalamic relay nuclei, which normally transmit sensory information to the cortex at high rates, switch to a burst-firing mode that drastically reduces the flow of external information. The cortex is, during sleep, partially decoupled from the external world, operating in a state of relative isolation, that is, from a quantum mechanical perspective, precisely the condition that would be expected to reduce environmental decoherence and allow quantum coherence to persist for longer periods. If quantum coherence in the brain is maintained by mechanisms similar to those discovered in photosynthesis and bird navigation biological systems that exploit quantum effects at body temperature, as we discussed in our investigation of twin entanglement, then the reduction of external decoherence during sleep could allow the brain's quantum states to maintain coherence for longer periods. The microtubules that Penrose and Hameroff have identified as the site of quantum processes in consciousness would be less disturbed by environmental measurement. The quantum superpositions that constitute, in their framework, the physical basis of conscious experience would last longer, extend further, and potentially involve a larger number of quantum states. And if those superpositions involve states that are correlated with other branches of the multiverse, if the brain's quantum state during the reduced decoherence of sleep retains some residual coherence with the versions of itself in neighboring branches, then the dreaming brain would have access, however faint and however brief, to information from those other branches. This is the quantum timeline hypothesis of dreaming. It proposes that dreams are not merely internal simulations generated by the sleeping brain from stored memories and random activation. They are, at least in part, brief glimpses into the probable timelines of quantum reality, fleeting contacts with the other branches of the multiverse that the decoherence barrier normally makes invisible. The vivid imagery, the emotional intensity, the The sense of reality that characterizes dreams would be explained not by the sophistication of the brain's simulation machinery, but by the fact that the dream is not entirely a simulation. It is partially a perception of realities that exist in other branches of the quantum multiverse, filtered through the dreaming brain's reduced critical faculties and expressed in the symbolic, narrative language of the dream. There is a connection here to Wheeler's delayed choice experiment that deserves explicit attention. Wheeler showed that a measurement decision in the present can determine the behavior of a quantum system in the past. If the dreaming brain, with its reduced decoherence barrier, is making quantum measurements that interact with the probability amplitudes of neighboring branches, then the dream is not simply perceiving the future, it is participating in the selection of which branch becomes the dreamer's future. The precognitive dream would not be a passive preview of a predetermined future. It would be an active participation in the branching process, a quantum measurement that, by observing a particular possibility, increases the probability of that possibility becoming actual in the dreamer's waking timeline. The dream does not predict the future, it helps create it. This is speculative. It must be clearly stated that it has not been experimentally tested, and that the technical barriers to testing it are formidable. But it is not pseudoscience. It is built on established physics, the many worlds interpretation, the mechanism of decoherence, the quantum biology of warm biological systems, and it makes predictions that are, in principle, distinguishable from the predictions of conventional dream theories. Consider the predictions. If dreams are glimpses into other branches of the multiverse, then dream content should occasionally include information about events that have not yet occurred in this branch, but that have occurred in neighboring branches where the timeline diverges from ours at a recent quantum event. This would explain precognitive dreams, dreams that anticipate future events not as impossible violations of causality, but as perceptions of events that have already happened in a neighboring branch. The event has not yet occurred in your branch, but it has occurred in a branch that diverged from yours recently enough that the quantum coherence between the two branches has not yet fully decohered. Your dreaming brain, with its reduced decoherence barrier, catches a glimpse of the neighboring branch, and when the event subsequently occurs in your branch, as it will, if the branch divergence was recent and the probability of the event was high, the dream appears to have predicted the future. This would also explain the inconsistency of precognitive dreams. Not all dreams are precognitive, because not all dreams involve quantum coherence with neighboring branches. Most dreams are, as conventional neuroscience describes, internal simulations generated from stored memories and emotional processing. But occasionally, when the conditions are right, when the decoherence barrier is low enough, when the brain's quantum states are coherent enough, when the divergence between branches is recent enough, a genuine quantum timeline glimpse occurs. The precognitive content is mixed with conventional dream content, which is why precognitive dreams are never perfectly accurate. They are contaminated by the brain's own simulation processes, which overlay the quantum perception with narrative, symbolism, and emotional distortion. The quantum timeline hypothesis also explains another puzzling feature of dreams, the experience of being in places you have never been and meeting people you have never met, yet feeling a profound sense of familiarity. In conventional dream theory, this is attributed to the brain combining fragments of stored memories into novel configurations. But in the quantum timeline framework, the familiarity may be genuine. You may be perceiving a place that you have actually visited in another branch of the multiverse, a branch in which you made different choices that led you to different locations. The familiarity is not false recognition. It is real recognition of a reality that you have experienced in another branch but not in this one. The physicist Henry Stapp, whose work on quantum mechanics and consciousness we have encountered in previous investigations, has proposed a framework that is compatible with the quantum timeline hypothesis. Stapp argues that conscious choices involve quantum events in the brain specifically, the selection of which neural pattern becomes actualized from among the many patterns that exist in superposition. In the many worlds framework, every possible neural pattern is actualized in some branch. But the conscious experience of the observer follows one specific branch, the branch in which a specific pattern was selected by a specific act of conscious attention. Stapp invokes the quantum Zeno effect to explain how consciousness stabilizes one branch. By repeatedly attending to a specific neural pattern, the conscious mind prevents that pattern from decohering into a superposition, effectively freezing the brain into one specific branch of the multiverse. Waking consciousness, in Stapp's framework, is the continuous application of quantum Zeno stabilization, the ongoing act of attention that keeps the brain locked into one branch. This framework elegantly resolves a puzzle that has troubled consciousness researchers for decades. Why does consciousness feel like a single, continuous stream rather than a branching, splitting, multiplying process? If the universe is constantly branching, why do you experience only one branch? Stapp's answer is that the quantum Zeno effect, the continuous, focused application of conscious attention, is what creates the experience of a single timeline. Attention stabilizes one branch. It prevents the quantum state from spreading across the landscape of possibilities. It holds the brain, and therefore the experience, in one definite configuration. The single stream of consciousness is not given. It is achieved, maintained, moment by moment, by the ongoing effort of attention. And when that effort relaxes, when attention wanders, when focus dissolves, when the prefrontal executive system goes offline, the single stream begins to fragment, to spread, to explore the neighboring branches that attention normally excludes. This is exactly what happens at the onset of sleep. The hypnagogic state, the transitional period between waking and sleeping, is characterized by bizarre, vivid, fragmentary imagery that appears to come from nowhere. Faces you have never seen, places you have never visited, scenes that bear no relation to your waking life flash through your awareness with startling clarity. Conventional neuroscience attributes this to the random activation of visual memory circuits as the cortex transitions from waking to sleeping modes. But in Stapp's framework, the hypnagogic imagery may be the first glimpses of neighboring branches as the quantum Zeno stabilization weakens and consciousness begins to drift across the timeline landscape. The fragments are not random. They are real experiences from real branches that are briefly accessible as the decoherence barrier thins during the transition to sleep. Now consider what happens when waking consciousness withdraws. During sleep, the prefrontal cortex, the seat of executive attention, the region that directs the focus of consciousness, goes offline. The quantum Zeno stabilization weakens. The brain's quantum states are no longer being held in one definite configuration by the focusing power of attention. They are free to evolve, to superpose, to explore the neighboring branches of the quantum landscape that waking attention normally excludes. In this framework, dreaming is what happens when consciousness stops stabilizing one branch and begins to drift across the quantum landscape. The dream is not a simulation. It is an exploration, a journey through the probability space of the multiverse, guided not by sensory input or executive control, but by the brain's quantum dynamics, freed from the constraints of waking stabilization. The vivid, immersive, emotionally intense experience of the dream is the subjective experience of consciousness moving through the branches of the multiverse, touching one timeline here, another there, picking up fragments of experience from branches that are close enough to your own to be coherent, but different enough to be surprising. This is, admittedly, a radical hypothesis. It pushes beyond what current science can confirm, but it has the virtue of explaining features of dreaming that no conventional theory can account for. The occasional precognitive content, the sense of visiting real but unfamiliar places, the profound emotional resonance of dream experiences that have no basis in the dreamer's personal history, and the universal human intuition shared across every culture and every century, that dreams are not merely internal fantasies but contacts with something real. And here is where the contemplative traditions enter, with a precision that elevates them from cultural curiosity to investigative framework. In Buddhism, the concept of dream yoga milam, one of the 6 yogas of Naropa, is not a practice of dream interpretation, it is a practice of dream navigation. The practitioner trains, through years of disciplined meditation, to maintain full conscious awareness during the dream state, to be lucid within the dream, not as an occasional accident, but as a deliberate, sustained capacity. And the purpose of this lucidity is not entertainment or self-exploration. It is the direct investigation of the nature of reality. The Tibetan Buddhist tradition describes the dream state as a bardo, an intermediate state between waking and deep sleep, analogous to the bardo between death and rebirth. In the bardo of dreaming, the ordinary constraints of physical reality are loosened. Time, space, causality, and personal identity are fluid rather than fixed. The practitioner who has trained in dream yoga can navigate this bardo with awareness and intention, exploring the landscape of the dream, not as a passive victim of the brain's random activations, but as a conscious agent investigating the structure of a reality that is, in the Buddhist understanding, no less real than the waking world. The Dzogchen tradition goes further. It teaches that the dream state and the waking state are equally illusory, or, more precisely, equally real. Neither one is the true reality. Both are manifestations of the deeper ground of awareness Rigpa that underlies all states of consciousness. The purpose of dream yoga is not to discover that dreams are real. It is to discover that waking is also a dream, that the apparently solid, stable, objective world of waking experience is as much a construction of consciousness as the fluid, shifting, subjective world of the dream. The difference between waking and dreaming is not a difference between reality and illusion. It is a difference between 2 modes of construction, 2 ways in which consciousness renders the informational ground into experiential form. If the quantum timeline hypothesis is correct, the Dzogchen insight acquires a physical interpretation. Waking consciousness is the experience of being locked into one branch of the multiverse by the quantum Zeno stabilization of executive attention. Dreaming consciousness is the experience of drifting across branches when the stabilization relaxes. And Rigpa, the ground awareness that underlies both, is the consciousness that is not committed to any particular branch, that does not mistake any single timeline for the whole of reality, that sees the multiverse for what it is, a vast, branching, interconnected landscape of possibility, in which every branch is real and no branch is the final truth. In Hinduism, the Yoga Vasistha, one of the most philosophically sophisticated texts in the Sanskrit tradition, contains extended passages that describe reality itself as a dream of Brahman. The physical universe, in this framework, is not a solid, objective, independently existing reality. It is a dream that the cosmic consciousness is having a dream that includes within it the experience of waking up, the experience of going to sleep, and the experience of dreaming within the dream. The levels of reality nested inside each other, dreams within dreams within dreams, correspond, in the quantum framework, to branches within branches within branches of the multiverse. Each level is real within its own context. None is absolutely real, and the consciousness that moves between them is the only thing that is present at every level, in every branch, in every dream. The Yoga Vasistha tells the story of a sage named Lila, whose husband dies, and who, through the power of her contemplation, enters a realm in which she encounters other versions of her husband, living other lives, in other worlds, all existing simultaneously. She discovers that the world she thought was the only reality is just one among countless worlds, each one as vivid and as complete as her own, each one containing beings who are convinced that their world is the only one. The sage Vasistha explains to her that all of these worlds are dreams of Brahman, that reality is a vast, branching tree of experiential possibilities, all of them real, all of them simultaneously existing, and all of them ultimately rooted in the same conscious ground. This ancient narrative is, structurally, a description of the many worlds multiverse, multiple simultaneously existing realities, each one containing conscious beings who believe their reality is the only one, all of them branches of a single underlying process, all of them real. The language is different, the cultural context is different, the investigative method is different, but the structure is the same. The Australian Aboriginal concept of the dream time, or, more accurately, the dreaming, offers perhaps the most radical parallel to the quantum timeline framework. In Aboriginal cosmology, the dream time is not a historical period that ended long ago. It is a dimension of reality that exists simultaneously with the physical world, interpenetrating it at every point. The dream time is the realm in which the ancestral beings created the landscape, the animals, and the laws of nature. But it did not stop creating when the physical world was formed. The dream time is still active, still generating, still sustaining the physical world at every moment. And it is accessible to human consciousness through dreams, through ceremony, and through the altered states of awareness that Aboriginal elders have cultivated for tens of thousands of years. The dream time is not the past. It is the eternal present, a timeless ground from which the temporal world is continuously projected, and it is more real than the physical world, not less. The physical world is the dream time's expression. The dream time is the physical world's source. When an Aboriginal person enters the dream time through dreaming or ceremony, they are not retreating into fantasy. They are accessing the deeper level of reality from which the everyday world emerges. This maps with extraordinary precision onto the quantum timeline framework. The dream time is the universal wave function, the totality of all possible branches, all possible configurations, all possible realities existing simultaneously outside of time. The physical world is one branch of this totality, one particular actualization of the infinite possibilities contained in the wave function. And dreaming is the state in which consciousness loosens its attachment to one particular branch and begins to perceive the larger landscape of possibility from which that branch emerged. In Islam, the Hadith tradition distinguishes between the world of images, alam al-mithal, and the physical world. The alam al-mithal is an intermediate realm between the physical and the divine, a realm of forms and experiences that is real in its own right, but not identical to physical reality. It is the realm that consciousness enters during dreams and during the bardo after death. Ibn Arabi describes the alam al-mithal as a realm in which meaning takes form, in which abstract realities that have no physical shape in the material world acquire sensory form and become experienceable. The dream, in this framework, is not the brain generating random imagery. It is consciousness entering a realm where information that normally exists in a non-sensory form becomes visible, audible, and tangible. The alam al-mithal is, structurally, a description of the quantum probability space. In the many worlds framework, every possible outcome of every quantum event exists as a real but non-actualized possibility in the universal wave function. These possibilities have no sensory form in any single branch. They are mathematical amplitudes, probability distributions, quantum superpositions, but they are real, they contain information, and if consciousness can access them during dreaming, when the decoherence barrier is reduced, Then, the dream is the experiential form of quantum possibility, the way that abstract probability amplitudes feel from the inside when consciousness encounters them directly. In the next stage of this investigation, we will bring together the neuroscience, the quantum physics, and the contemplative traditions into a unified framework. We will examine what happens to the brain during the specific moments when precognitive or anomalous dream content appears. We will explore the relationship between dream yoga, lucid dreaming, and the quantum Zeno effect. And we will ask whether the ancient practice of conscious dreaming, the deliberate training of awareness to navigate the dream state with clarity and intention, is, in the language of quantum mechanics, the training of consciousness to navigate the multiverse. The branches are real, the dreams may be the windows, and the question of what you see when you look through those windows may depend on how clearly you have learned to look. We have now constructed two pillars of our investigation. The neuroscience has shown us that dreaming is a sophisticated, purposeful, neurologically active state of consciousness, not noise, not accident, not the brain's screensaver, but an immersive simulation generated by the brain's most advanced machinery, capable of solving problems, processing emotions, and occasionally accessing information that no conventional theory can explain. The quantum physics has shown us that if the many worlds interpretation is correct, every possible outcome of every quantum event is realized in a real, physically existing branch of the multiverse, and that the decoherence barrier separating these branches may thin during sleep, when the brain's interaction with the external sensory environment is drastically reduced. Now we must bring these two pillars together and ask the hardest question: what actually happens in the brain during the moments when anomalous dream content, precognitive imagery, information from unknown sources, contact with realities that feel more real than waking life appears? And is there a practice, a discipline, a trainable skill that allows the dreamer to access these moments deliberately rather than accidentally? The answer to the second question is yes, and it has existed for over 1,000 years. But first, the neuroscience. The most detailed neuroimaging studies of dreaming have been conducted using high-density EEG, which can capture the electrical activity of the brain with millisecond precision across the entire cortical surface. In 2017, a landmark study by Francesca Ciclari and colleagues at the University of Wisconsin-Madison Giulio Tononi's research group identified a specific neural signature that distinguishes dreaming from dreamless sleep. By waking subjects at random intervals throughout the night and asking whether they had been dreaming, Ciclari's team correlated the dream reports with the brain activity recorded in the moments before awakening. They found that dreaming was associated with decreased low-frequency activity in a specific posterior cortical region they called the posterior hot zone, a region encompassing the visual cortex, the parietal cortex, and parts of the temporal cortex. When this region showed decreased slow-wave activity and increased high-frequency activity, subjects reported dreams. When it showed high slow-wave activity, subjects reported dreamless sleep. This finding is important for several reasons. First, it identified a specific brain region as the neural correlate of dreaming, not the brainstem, as Hobson and McCarley had proposed, but a posterior cortical zone that is associated with sensory experience, spatial processing, and the construction of perceptual reality. Second, it showed that the dreaming brain is not uniformly active. It is selectively active, with some regions highly engaged and others relatively quiet. The posterior hot zone is on while the prefrontal cortex is largely off. This is the neural signature of a state in which perceptual experience is vivid and immersive, but critical evaluation is absent. A state in which the brain generates reality without questioning it. The posterior hot zone finding also resolved a long-standing puzzle about why dream content is so heavily visual. The posterior hot zone includes the primary and secondary visual cortices, which are the most metabolically active brain regions during REM sleep. The brain, during dreaming, is literally seeing, generating visual experiences using the same neural architecture that processes visual input during waking. But in the absence of retinal input, what is the visual cortex seeing? The conventional answer is internally generated patterns, reconstructed from memory and driven by limbic activation. The quantum timeline answer adds a possibility. The visual cortex may be processing visual information from a source that is not memory and not the retina. A source that is accessible only when the normal sensory channels are closed and the brain's quantum states are free to cohere across branches. In 2013, a team led by Tomoyasu Horikawa at the ATR Computational Neuroscience Laboratories in Kyoto achieved something that would have seemed like science fiction a decade earlier. They decoded dream content from brain activity. Using machine learning algorithms trained on the neural patterns associated with specific visual categories during waking perception, Horikawa's team was able to predict, from the sleeping subject's brain activity alone, the visual content of their dreams with statistically significant accuracy. When the subject was dreaming about a car, the brain showed the same pattern as when they were looking at a car while awake. When they were dreaming about a person, the brain showed the person pattern. The dream was not a vague, amorphous experience that the brain narrativized after the fact. It was a specific, decodable, neurologically precise perception as real, from the brain's perspective, as any waking perception. This result has been replicated and extended by multiple groups, and it confirms the central insight of the posterior hot zone finding. The dreaming brain is not generating random imagery. It is perceiving specific content through specific neural circuits with specific, decodable, objectively measurable precision. The question of what it is perceiving, whether stored memories, internal simulations, or information from quantum branches, remains open. But the neural machinery of dream perception is as precise and as specialized as the machinery of waking perception. Whatever the dream is, the brain takes it very seriously. Third, and most importantly for our investigation, Ciclari's study found that the specific content of dreams could be predicted from the pattern of activity in the posterior hot zone. Dreams involving faces activated the fusiform face area. Dreams involving spatial navigation activated the parahippocampal place area. Dreams involving movement activated the motor cortex. The dream content was not random. It was generated by the same specialized brain regions that process the corresponding content during waking experience. The brain does not dream by activating random circuits. It dreams by activating the specific circuits that would process the corresponding experience if it were occurring in the waking world. This finding transforms our understanding of what a dream is. It is not a story that the brain tells itself, as the activation synthesis model proposed. It is a virtual reality that the brain constructs using the same neural machinery that constructs waking reality. The dream is a reality simulation so faithful that the simulating brain cannot distinguish it from the thing being simulated. And the question that the quantum timeline hypothesis raises is, what if the simulation is so faithful because it is not entirely a simulation? What if the specialized circuits are activating, not because they are randomly stimulated, but because they are processing input from a genuine source, a source that is not the external physical world, but the neighboring branches of the quantum multiverse? There is a specific neural phenomenon that may be relevant here, the gamma burst. Gamma oscillations are high-frequency brain waves, typically between 30 and 100 Hz, that are associated with conscious awareness, attention, and the binding of information from different brain regions into a unified perceptual experience. During waking, gamma oscillations are present throughout the cortex and are thought to be the neural signature of conscious experience itself. During most of sleep, gamma activity is suppressed. But during specific moments of REM sleep, moments that correlate with the most vivid, most emotionally intense, and most memorable dreams, sudden bursts of gamma activity appear, particularly in the frontal and temporal regions. In 2009, Ursula Voss and colleagues at the University of Bonn published a study in the journal Sleep, showing that lucid dreams, dreams in which the dreamer becomes aware of dreaming, are characterized by a dramatic increase in gamma oscillations in the frontal cortex. Specifically, the gamma activity during lucid dreaming peaked at 40 Hz, the same frequency that has been associated with conscious awareness, with the binding problem in perception, and, intriguingly, with the meditative states of advanced Buddhist practitioners. This last connection deserves careful attention. In 2004, Antoine Lutz and colleagues at the University of Wisconsin-Madison again, Tononi's group published a groundbreaking study in the Proceedings of the National Academy of Sciences showing that long-term Tibetan Buddhist meditators, when engaged in compassion meditation, generated sustained gamma oscillations of extraordinary amplitude and coherence. The gamma activity was far greater than anything previously recorded in a normal human brain. It was synchronized across widely separated brain regions, indicating a degree of neural integration that exceeds ordinary waking consciousness. And it was centered at approximately 40 Hz, the same frequency that Voss found in lucid dreams. The convergence is remarkable. Lucid dreaming and advanced meditation produce the same neural signature, high amplitude, highly coherent 40 Hz gamma oscillations. In both states, the practitioner reports heightened awareness, clarity, and a sense of reality that exceeds ordinary waking experience. In both states, the default mode network, the brain's autobiographical, self-referential system, is active but configured differently from its waking pattern, suggesting a restructured sense of self. And in both states, the experiential reports describe contact with a reality that feels more real, more vivid, and more fundamental than ordinary waking experience. If the 40 Hz gamma signature is the neural correlate of heightened conscious awareness, and if this signature appears both in lucid dreaming and in advanced meditation, then the two practices may be accessing the same state of consciousness through different entry points. Meditation reaches it by intensifying waking awareness until it transcends its ordinary limitations. Lucid dreaming reaches it by awakening within the dream, until dream awareness transcends its ordinary limitations. Both paths lead to the same destination, a state of consciousness that is more integrated, more coherent, and more aware than ordinary waking or ordinary dreaming. And here is where the quantum framework becomes directly relevant. The 40 Hertz gamma oscillation has been proposed by several researchers, including Penrose and Hameroff, as the frequency at which quantum coherence in brain microtubules might manifest at the macroscopic level. In the orchestrated objective reduction model, conscious moments arise from quantum computations in microtubules that collapse or, in many worlds' language, branch at a rate of approximately 40 times per second. Each conscious moment is a quantum event. Each quantum event is a branching of the multiverse, and the 40 Hertz gamma oscillation is the rhythmic signature of this process, the neural drumbeat of consciousness branching through the quantum landscape. The significance of 40 Hz extends beyond neuroscience. It is the frequency at which many biological systems exhibit coherent oscillations. The heart's electromagnetic field oscillates at frequencies that include the 40 Hz range. The gut's enteric nervous system generates oscillations in the same band. And intriguingly, the Schumann resonances, the electromagnetic standing waves in the cavity between the Earth's surface and the ionosphere, generated by lightning discharges, have a fundamental frequency of 7.83 Hz, with harmonics that extend into the 40 Hz range. Some researchers have speculated that the brain's 40 Hz oscillations may be entrained by or resonant with these planetary electromagnetic rhythms, creating a coupling between the brain's quantum processes and the electromagnetic environment of the Earth. This is speculative, but it raises the fascinating possibility that the brain's quantum coherence is not entirely internal, that it may be supported, amplified, or modulated by the planet's own electromagnetic field. If this is correct, then the enhanced 40 Hz gamma oscillations in lucid dreaming and advanced meditation represent an enhanced rate or an enhanced coherence of quantum processing in the brain. The brain, during these states, is performing more quantum operations per second, or performing them with greater integration across brain regions, or both. And if the quantum timeline hypothesis is correct, if dreaming involves brief contacts with neighboring branches of the multiverse, then the enhanced quantum coherence of lucid dreaming would represent not merely heightened awareness within one branch, but heightened awareness across branches. The lucid dreamer is not just more conscious within the dream, they are more conscious of the quantum landscape, more able to perceive the neighboring timelines, more able to navigate between them, more able to access information from branches that ordinary dreaming touches only randomly and briefly. This is precisely what the contemplative traditions describe, and their descriptions are not vague. They are technically precise, practically oriented, and remarkably consistent across cultures that had no contact with each other. In the Tibetan Buddhist tradition, dream yoga is not a casual practice. It is one of the 6 yogas of Naropa, a set of advanced meditation techniques transmitted from the Indian Mahasiddha Naropa to the Tibetan translator Marpa in the 11th century, and subsequently practiced by generations of Kagyu and Nyingma practitioners. The 6 yogas include Tummo, inner heat, Ozal, clear light, Phawa, consciousness transference, Bardo navigation of intermediate states, illusory body, and Milam dream yoga. The practice of Milam proceeds through stages that map with uncanny precision onto the neuroscience of lucid dreaming and the quantum framework we have constructed. The first stage is recognition, learning to recognize that you are dreaming while the dream is occurring. This corresponds to the activation of prefrontal gamma oscillations that Voss identified as the neural correlate of lucidity. The practitioner trains, through daytime practices of reality checking and intention setting, to activate the critical awareness that is normally suppressed during dreaming. The prefrontal cortex, which goes offline during ordinary REM sleep, is partially reactivated. The dreamer becomes aware within the dream. The second stage is transformation, learning to intentionally change the content of the dream. The lucid dreamer discovers that the dream environment is malleable, that it responds to intention, that objects can be transformed, that the dreamer can fly, teleport, summon objects, and alter the dream landscape through acts of will. In neuroscientific terms, this corresponds to the restoration of executive control over the dream simulation. The prefrontal cortex is not merely aware that the dream is a dream. It is exerting top-down influence over the posterior hot zone, directing the dream generation machinery rather than passively experiencing its output. The third stage is multiplication, learning to multiply one's dream body, to be in multiple places simultaneously, to experience the dream from multiple perspectives at once. This stage has no direct parallel in Western neuroscience, because Western neuroscience has no framework for understanding how a single consciousness could occupy multiple locations simultaneously. But in the quantum framework, this stage corresponds to the conscious exploration of branching. The practitioner is training consciousness to be simultaneously aware of multiple branches of the quantum landscape, not serially experiencing one branch and then another, but simultaneously experiencing multiple branches at once. The multiplication of the dream body is the experiential correlate of consciousness spreading across the multiverse. The multiplication stage is the most radical and the most difficult to interpret within a conventional neuroscientific framework. But within the quantum framework, it has a natural explanation. If consciousness during lucid dreaming is not confined to one branch of the multiverse but is beginning to cohere across branches, then the multiplication of the dream body is the experiential consequence of simultaneous awareness across multiple branches. The practitioner is not creating copies of themselves within a single dream. They are becoming aware of the versions of themselves that already exist in neighboring branches, versions that diverged from their own timeline at recent quantum events, and that are still close enough in the quantum landscape to be perceivable when the decoherence barrier is sufficiently thin. Advanced millennium practitioners report that the multiplication stage is accompanied by a qualitative shift in the nature of dream awareness. The dream no longer feels like a personal, private experience. It feels like a shared field, a space in which multiple perspectives coexist, multiple storylines unfold simultaneously, and the boundaries between self and other, between dreamer and dream, become permeable. This is consistent with what the quantum framework predicts. As consciousness coheres across branches, the strict individuation that characterizes single-branch awareness begins to dissolve. The dreamer is no longer one person in one world. They are one awareness, experiencing multiple worlds simultaneously. The fourth and final stage is the recognition of the dream as the nature of all reality. The practitioner, having learned to recognize, transform, and multiply within the dream, applies the same awareness to waking experience. They recognize that waking reality, like dream reality, is a construction of consciousness. They recognize that the apparent solidity, stability, and objectivity of the waking world is, like the dream, a simulation, a rendering of information by the brain's reality construction machinery. And they recognize that the consciousness which is aware of both the dream and the waking state is not bound to either one. It is the awareness that transcends both the ground of all experience, the witness of all constructions, the rigpa that is present in every state and identical in every branch of the multiverse. This four-stage progression: recognition, transformation, multiplication, and the recognition of ultimate reality is, in the quantum framework, a training program for navigating the multiverse. Stage 1. Learn to be conscious within a branch. Stage 2. Learn to influence the branch. Stage 3. Learn to perceive multiple branches simultaneously. Stage 4. Learn to recognize that all branches are constructions from a single, unconditioned ground of awareness. In Islam, the practice of dream cultivation, while not formalized into a progressive system like the Tibetan millennia, follows a structurally similar logic. The Prophet Muhammad instructed his companions in the art of receiving true dreams through specific practices: sleeping in a state of ritual purity, reciting specific surahs before sleep, sleeping on the right side, and making a sincere intention to receive guidance. These are not arbitrary rituals. They are practices designed to prepare consciousness for a particular quality of dream experience, to shift the dreamer from the confused, ego-driven dream state to the receptive, clarified state in which true dreams become possible. The Islamic scholar Ibn Khaldun, writing in the 14th century, provided a sophisticated theoretical framework for understanding how the soul accesses information during sleep. In his Muqaddimah, Ibn Khaldun described the human soul as existing on a continuum between the material world and the spiritual world. During waking, the soul is oriented toward the material world through the senses. During sleep, the sensory connection is severed, and the soul turns toward the spiritual world, toward what he called the world of the unseen, from which it can receive information that is not available through sensory channels. The quality of information received depends on the clarity of the soul, on the degree to which it has been purified of attachments, distractions, and ego distortions that cloud its receptive capacity. Ibn Khaldun's framework maps onto the quantum timeline hypothesis with striking precision. The world of the unseen corresponds to the quantum landscape of branching timelines, the multiverse of possibilities that is normally invisible to waking consciousness because the decoherence barrier keeps it hidden. The turning of the soul toward this world during sleep corresponds to the reduction of decoherence as sensory input ceases and the brain's quantum states become more coherent. And the clarity of the soul, the purification that determines the quality of dream information, corresponds to the degree of quantum coherence that the brain can maintain. A brain cluttered with unresolved emotions, compulsive thoughts, and chronic stress is a brain with high internal decoherence, high noise, low signal, poor quantum coherence. A brain that has been calmed, focused, and purified through spiritual practice is a brain with lower internal decoherence, lower noise, higher signal, better quantum coherence. The spiritual practices that prepare the soul for true dreams are, in the quantum framework, practices that optimize the brain's quantum coherence. The great Islamic philosopher and theologian Al-Ghazali, writing in the 11th century, provided an even more direct connection between dreaming and the perception of alternative realities. In his masterwork, The Revival of the Religious Sciences, Al-Ghazali argued that the dream state provides empirical evidence for the existence of realities beyond the physical world. He wrote that every person, every night, experiences a world that is as vivid and as real as the waking world, but that is not the waking world. This proves, Al-Ghazali argued, that consciousness is not limited to physical reality, that it has the capacity to perceive realities that are not accessible through the physical senses. The dream is not evidence that the brain generates fantasies. It is evidence that consciousness has access to dimensions of reality that the physical senses cannot reach. Al-Ghazali went further. He argued that the relationship between the dream world and the waking world is analogous to the relationship between the waking world and the afterlife. Just as the dreamer, upon waking, recognizes that the dream world was real but limited a subset of the larger reality that waking reveals, so the person who dies and enters the afterlife will recognize that the waking world was real but limited a subset of the larger reality that death reveals. Each state of consciousness opens onto a wider reality than the previous state. The dream opens onto more than waking can perceive. Death opens onto more than the dream can perceive. And each transition feels, from the inside, like waking up. This progressive expansion of consciousness through successive states, each one revealing a wider reality than the last, is exactly what the quantum timeline hypothesis describes in physical terms. Waking consciousness perceives one branch, dreaming consciousness perceives neighboring branches. And the deepest state of awareness, the state that the traditions call enlightenment, moksha, fana, or turiya, perceives the entire quantum landscape at once, without the limitations imposed by attachment to any single branch. In Hinduism, the Yoga Sutras of Patanjali describe a specific meditation practice called svapna jnana, knowledge born from the dream state. Sutra 1.38 states, "Or by meditating on knowledge that comes from dream or deep sleep, the mind becomes stabilized." Patanjali is not suggesting that dreams are a pleasant topic for contemplation. He is identifying the dream state as a legitimate source of knowledge, a source that, when meditated upon, leads to the stabilization of consciousness. This is consistent with the quantum framework. The information accessed during dreaming, when integrated through meditative contemplation, helps consciousness maintain its coherence and stability, its ability to remain centered in awareness rather than being dispersed across the noise of daily life. The Mandukya Upanishad, which we have encountered in previous investigations, provides the deepest Hindu framework for understanding the relationship between dream consciousness and reality. The four states of consciousness: waking, Vaishvanara, dreaming, Tajasa, deep sleep, Prajna, and Turiya, are not a hierarchy from real to unreal. They are a map of the dimensions of consciousness, each one revealing a different aspect of reality. Vaishvanara perceives the gross, material world. Tajasa perceives the subtle world, the realm of forms that are real but not material, the realm that the quantum framework would identify as the landscape of possible but not actualized realities. Prajna rests in the undifferentiated ground from which both gross and subtle worlds emerge. And Turiya is the witness of all three, the pure awareness that is present in waking, dreaming, and deep sleep, that transcends all three, and that is identical in nature across all branches of the multiverse. The Mandukya's description of Tajasa, the dream consciousness, is particularly relevant. Tajasa is described as the enjoyer of the subtle, the consciousness that experiences the subtle realm of forms and possibilities that are not accessible to waking perception. In the quantum framework, the subtle realm is the quantum landscape of probability amplitudes, the branches of the multiverse that exist as real possibilities, but that are not actualized in the dreamer's waking branch. Tajasa, the dream consciousness, is the mode of awareness that can perceive these possibilities directly, that can experience the multiverse, not as an abstract mathematical description, but as a lived, felt, immersive reality. In Christianity, the tradition of dream revelation runs through the entire biblical narrative. God communicates through dreams in Genesis, in Daniel, in Matthew, in Acts. The prophet Joel declares, "Your old men shall dream dreams, your young men shall see visions." This is not a prediction about the frequency of dreaming. It is a promise about the quality of dreaming, a promise that the divine will use the dream channel to communicate directly with human consciousness. The early church took this promise seriously. Tertullian wrote that dreams are one of the ways God communicates with humanity. Synesius of Cyrene, a bishop and Neoplatonist philosopher, wrote an entire treatise on dreams in which he argued that the dream is the soul's natural mode of receiving divine communication, because during sleep, the soul is freed from the distractions of the senses and can attend to the subtle signals from the spiritual world that waking consciousness normally drowns out. Synesius's framework is remarkably compatible with both the neuroscience and the quantum hypothesis. The sensory distractions of waking correspond to the environmental decoherence that locks the brain into one branch. The freedom of sleep corresponds to the reduction of decoherence that allows the brain's quantum states to cohere across branches. And the subtle signals from the spiritual world correspond to the information from neighboring branches of the multiverse that becomes accessible when the decoherence barrier thins. There is a remarkable practical convergence in the dream preparation techniques across these traditions that deserves explicit attention. The Islamic practice of sleeping in ritual purity, reciting specific surahs, and setting an intention before sleep. The Buddhist practice of visualization, mantra recitation, and intention setting before sleep. The Hindu practice of pranayama, meditation, and sankalpa, conscious intention before sleep. The Christian practice of evening prayer, examination of conscience, and commending the soul to God before sleep. Despite the vast differences in theology, cosmology, and cultural context, these traditions have independently converged on the same practical formula: purify the mind, focus the intention, quiet the internal noise, and consciously orient awareness toward the subtle realm before entering sleep. In the quantum framework, every element of this formula has a functional explanation. Purification of the mind reduces internal decoherence, the mental noise that prevents quantum coherence from building. Focusing the intention engages the quantum Zeno effect, Directing attention toward a specific target increases the probability that the corresponding quantum states will be stabilized. Quieting internal noise reduces the thermal fluctuations that destroy quantum coherence. And orienting awareness toward the subtle realm is, literally, turning the attention away from the external sensory world that produces environmental decoherence and toward the internal quantum landscape that becomes accessible when environmental decoherence is reduced. The traditions did not know about quantum mechanics, but they discovered, through millennia of systematic experimentation with consciousness, the precise conditions that quantum mechanics would predict are necessary for enhanced quantum coherence during sleep. The practices work, they produce more vivid, more meaningful, more information-rich dreams, and the quantum framework may explain why. The convergence across these traditions is now too precise and too consistent to be dismissed as coincidence. The Tibetan Buddhists train consciousness to navigate the dream state through progressive stages of awareness. The Islamic scholars describe the soul turning toward the world of the unseen when sensory input ceases. The Hindu yogis identify the dream state as a distinct dimension of consciousness with its own realm of perception. The Christian theologians describe dreams as a channel for divine communication when the noise of the senses is silenced. And the neuroscience shows us a brain that, during dreaming, is actively constructing immersive realities using specialized neural circuits, with enhanced connectivity between regions, reduced prefrontal control, and in lucid dreaming and advanced meditation, a distinctive 40 Hz gamma signature that may represent enhanced quantum coherence. Every one of these traditions prescribes practices for improving the quality and clarity of dream experience. Everyone describes the dream state as a legitimate mode of accessing information that waking consciousness cannot reach. And everyone asserts that the dream is not less real than waking, but differently real. A window into a dimension of reality that the constraints of waking perception normally conceal. The quantum timeline hypothesis provides the physics for all of this. The many worlds interpretation provides the branches. The decoherence mechanism provides the barrier. The reduction of sensory input during sleep provides the thinning of the barrier. The quantum Zeno effect provides the stabilization mechanism that locks waking consciousness into one branch. And the relaxation of that stabilization during sleep provides the freedom that allows consciousness to drift across the quantum landscape. What we are describing is not a fringe theory bolted onto mainstream science. It is a synthesis that emerges naturally when you take the established findings of neuroscience, the posterior hot zone, the gamma oscillations, the content-specific neural activation, the lucid dreaming communication experiments, and combine them with the established framework of quantum mechanics, many worlds, decoherence, the quantum Zeno effect, biological quantum coherence, and then notice that the result matches, with extraordinary structural precision, the descriptions provided by every major contemplative tradition on Earth. No single element of this synthesis is proven beyond doubt, but the coherence of the whole is striking, and it points toward a unified understanding of dreaming that transcends the limitations of any single investigative tradition. The pieces fit. Not perfectly, science is never perfect, and speculation is never certain, but they fit with a coherence and a precision that demands serious attention rather than reflexive dismissal. In the final stage of this investigation, we will bring everything together into a single picture. We will ask the ultimate question: are dreams brief glances into the probable timelines of quantum reality? And we will explore what the answer means for the nature of consciousness, the structure of reality, and the ancient human intuition that the world we see when we close our eyes is not less real than the world we see when we open them, that it may, in fact, be more. We have now traveled the full arc of this investigation. We began in the sleep laboratory, where neuroscience revealed that dreaming is not noise but a sophisticated, purposeful, neurologically precise state of consciousness in which the brain constructs immersive realities using the same specialized circuits that process waking perception. We followed the trail into quantum mechanics, where the many worlds interpretation showed us that every possible outcome of every quantum event is realized in a real, physically existing branch of the multiverse, and that the decoherence barrier separating these branches may thin during sleep when sensory input ceases and the brain's quantum states are free to cohere across timelines. We examined the anomalous evidence, precognitive dreams, the Maimonides telepathy experiments, Behm's retroactive influence studies, and found a persistent, statistically significant signal that refuses to disappear despite decades of skepticism. And we listened to the contemplative traditions, the Tibetan dream yoga, the Islamic science of true dreams, the Hindu mapping of consciousness states, the Christian theology of dream revelation, the Aboriginal dream time, and found a unanimous, cross-cultural, millennia-old insistence that dreams are not fantasy but perception, not simulation but contact, not the brain talking to itself, but consciousness encountering a dimension of reality that waking perception cannot reach. Now we must bring all of this together and state, as clearly and as honestly as we can, what the evidence supports and what it suggests. Let us begin with what is established. Established fact 1. The brain during dreaming is performing real cognitive work. It is solving problems that the waking brain cannot solve. It is processing emotions in a neurochemical environment that allows the emotional charge to be separated from the informational content of memories. It is forming novel connections between brain regions that do not communicate during waking, producing creative insights and pattern recognition that waking consciousness cannot achieve. Dreaming is not idle time. It is one of the brain's most important operational modes, and evolution has preserved it with extraordinary fidelity across virtually every species that has a cortex. Established fact 2. The dream experience is neurologically indistinguishable from waking perception. The same brain regions that process visual input during waking process visual content during dreaming. The same motor circuits that generate movement commands during waking generate movement experiences during dreaming. The same emotional circuits that produce fear, joy, and desire during waking produce those same emotions during dreaming, often with greater intensity. For the brain, the dream is not a lesser version of reality. It is reality, processed through the same neural machinery at the same level of precision. Established fact 3. The boundary between the dreaming mind and the external world is not impermeable. Lucid dreaming experiments have demonstrated real-time, two-way communication between sleeping subjects and waking researchers. The dreaming brain can receive novel information from the external world, process it, solve problems with it, and communicate the solutions back. The dream is not a sealed chamber. It is a state of consciousness that can interact with the world outside the dream, which raises the question of whether it can also interact with worlds beyond the one that the waking brain normally perceives. Established fact 4. The neural signature of lucid dreaming is identical to the neural signature of advanced meditative states. Both produce high amplitude, highly coherent 4-0 Hertz gamma oscillations. Both are associated with enhanced awareness, clarity, and a sense of encountering reality at a deeper level than ordinary consciousness permits. And both are trainable. The capacity for lucid dreaming and the capacity for deep meditative awareness can be developed through systematic practice, just as the contemplative traditions have taught for millennia. Established fact 5. Every human culture in recorded history has attributed significance to dreams. This universality is itself a datum, When a belief appears independently in every culture, on every continent, across every century of recorded history, it is either the most successful delusion in the history of our species, or it is tracking something real about human experience that the materialist framework has not yet accommodated. The anthropological record shows that the attribution of significance to dreams is not a product of any particular cultural tradition, religious framework, or level of technological development. It appears in hunter-gatherer societies and in industrial civilizations, in theistic and atheistic cultures, in scientific and pre-scientific communities. The belief that dreams are meaningful, that they contain information beyond what the dreamer consciously knows, and that they occasionally reveal truths about the past, the present, or the future is as close to a human universal as any belief has ever been. Established fact 6. The brain does not distinguish between dream experience and waking experience at the neurological level. The same circuits fire, the same regions activate, the same neurotransmitter systems engage. The only difference is the source of input and the presence or absence of prefrontal critical evaluation. If you showed a neuroscientist an EEG recording and asked whether the subject was awake or dreaming during an active REM period, they could not tell the difference from the cortical activation alone. The brain treats dream experiences as real experiences. It processes them with the same precision, the same emotional weight, and the same neural resources that it devotes to waking perception. Whatever dreams are, the brain does not regard them as lesser. These are the established facts. They are not in dispute. Any theory of dreaming must account for all of them. Now let us state what the evidence suggests, but has not proven. Suggestion 1. Quantum coherence may play a functional role in the brain during dreaming. The reduction of sensory input during sleep reduces the environmental decoherence that normally locks the brain's quantum states into classical configurations. The quantum biology of photosynthesis and bird navigation has demonstrated that biological systems can maintain quantum coherence at body temperature. The Penrose-Hameroff model proposes that consciousness arises from quantum processes in microtubules, and the 4-0 Hertz gamma oscillation that characterizes both lucid dreaming and advanced meditation may be the macroscopic signature of enhanced quantum coherence in neural tissue. None of this has been definitively confirmed in the context of dreaming, but the individual components are established, and their convergence in the dreaming brain is suggestive. Suggestion 2. If the many worlds interpretation is correct, and if quantum coherence in the brain during dreaming allows residual connection to neighboring branches of the multiverse, then some dream content may represent genuine perception of events in other branches, other timelines in which different quantum outcomes were realized. This would explain precognitive dreams as perceptions of events that have already occurred in a neighboring branch and that will, with some probability, also occur in the dreamer's branch. It would explain the sense of visiting real but unfamiliar places as genuine perception of locations that the dreamer has visited in another branch. And it would explain the universal human intuition that dreams are contacts with something real because they are, not always, not reliably, but occasionally when the conditions are right, the decoherence barrier thins enough for a brief glimpse of the quantum landscape to filter through into the dream. Suggestion 3. The contemplative practices of dream cultivation, the purification, intention setting, and mental preparation prescribed by every major tradition may work by optimizing the brain's quantum coherence during sleep. Reducing mental noise reduces internal decoherence. Focusing intention engages the quantum Zeno effect. Quieting the senses reduces environmental decoherence. And training awareness to remain lucid during dreaming enhances the 4-0 Hertz gamma signature that may represent enhanced quantum processing. The traditions discovered, through millennia of experimentation with consciousness, the precise conditions that quantum mechanics would predict are necessary for enhanced access to the quantum landscape during sleep. Suggestion 4. The quantum timeline hypothesis makes specific, testable predictions that distinguish it from conventional dream theories. If dreaming involves quantum perception of neighboring branches, then the precognitive content of dreams should correlate with the quantum probability of the foreseen events. Events with high quantum probability, events that are likely to occur in many branches, not just one, should appear more frequently in precognitive dreams than low probability events. This is because neighboring branches are more likely to contain events with high quantum probability. A dream about a common event, like a phone call from a friend, would be more likely to be genuinely precognitive than a dream about a lottery win, because the phone call occurs in many branches while the lottery win occurs in very few. This prediction is testable, at least in principle, through large-scale, systematic dream journaling studies correlated with subsequent event tracking. A second testable prediction: if the 40 Hz gamma signature represents enhanced quantum coherence, then pharmacological agents that enhance gamma oscillations should increase the frequency and vividness of anomalous dream content, while agents that suppress gamma oscillations should decrease it. This could be tested using existing EEG technology and controlled sleep laboratory protocols. A third, testable prediction: if the contemplative practices that prepare consciousness for enhanced dream perception work by optimizing quantum coherence, then experienced meditators should show higher rates of anomalous dream content than non-meditators, and this effect should correlate with measurable differences in their sleep stage gamma oscillations. Preliminary evidence from the Lutz and Voss studies is consistent with this prediction, but a direct test in the context of dream anomaly research has not been conducted. These suggestions are speculative. They push beyond the current boundaries of confirmed science, but they are not pseudoscience. They are built on established physics, established neuroscience, and established experimental anomalies combined through logical inference into a framework that is testable, falsifiable, and consistent with everything that is currently known. Now, let us bring in the contemplative traditions for the final synthesis. Every major tradition we have examined makes a claim about dreaming that goes beyond what even the quantum timeline hypothesis proposes. The traditions do not merely say that dreams can access information from other timelines. They say that dreaming reveals something about the nature of reality itself, something that waking consciousness is structurally designed to conceal. In Buddhism, the ultimate purpose of dream yoga is not to have interesting dreams or to predict the future. It is to recognize that the waking world and the dream world are both constructions of consciousness, and that neither one is the fundamental reality. The practitioner who masters dream yoga does not become a better dreamer. They become a better waker, someone who recognizes, with the same clarity in waking life as in lucid dreams, that the apparently solid, stable, objective world is a construction of the mind, sustained by the mind, and dissolvable by the mind. The dream is the training ground. Waking is the examination. And the insight that the examination tests is the insight that Nagarjuna articulated 2,000 years ago. Nothing has inherent existence. Everything is dependently originated. Everything is empty of self-nature, and the consciousness that perceives this emptiness is itself empty, not nothing, but not a thing either. It is the open, luminous, boundaryless awareness that the Dzogchen tradition calls Rigpa, the awareness that is present in every state, in every branch of the multiverse, in every dream and every waking moment, unchanged by any of them. The quantum framework gives this insight a physical interpretation. If the universe is a branching multiverse, and if each branch is a construction generated by the collapse of quantum superpositions, then no branch is more real than any other. Each branch is a rendering of the universal wave function, a particular actualization of the infinite possibilities contained in the quantum code. The waking world is one rendering. The dream world is another, and the Rigpa that perceives both the awareness that is present in waking and in dreaming, and in every state between and beyond them, is not a rendering. It is the capacity for rendering. It is not a branch. It is the tree. It is not a wave. It is the ocean from which all waves arise. This Buddhist insight has a precise parallel in the language of quantum information theory. The universal wave function, the mathematical description of the entire multiverse in the many worlds framework, does not branch. Branching is what it looks like from inside a particular branch. From the perspective of the wave function itself, nothing ever branches, nothing ever collapses, nothing ever changes. The wave function evolves smoothly and unitarily, containing all possibilities simultaneously, forever. The branches that we experience are not real separations in the wave function. They are apparent separations, produced by decoherence, that create the illusion of distinct, independent timelines from within a reality that is, at the deepest level, one and undivided. Rigpa, in this framework, is the perspective of the wave function itself, the awareness that sees the whole, without being confused by the apparent separations. The enlightened mind does not perceive a different reality from the unenlightened mind. It perceives the same reality without the decoherence-induced illusion of separation. It sees the multiverse for what it is, one thing, appearing as many, with the appearance maintained by the decoherence that waking consciousness mistakes for reality. And the dream in this framework is the state in which the decoherence loosens just enough for the dreamer to catch a glimpse of the unity beneath the apparent multiplicity. The dream does not reveal a separate world. It reveals the connections between worlds that decoherence normally hides. It shows the dreamer, briefly and imperfectly, what the wave function looks like from inside when the walls between branches become thin. In Hinduism, this insight is expressed in the Mandukya Upanishad's teaching about Turiya. Turiya is not a state among states, it is the ground of all states. It is the awareness that is present in waking, dreaming, and deep sleep that transcends all three, and that is not affected by the transitions between them. When you fall asleep, Turiya does not sleep. When you dream, Turiya does not dream. When you wake, Turiya does not wake. Turiya is the unchanging witness of every changing experience, the screen on which every movie is projected, the silence in which every sound is heard, the space in which every object appears. And Turiya is not separate from the states it witnesses. It is their substance. It is what they are made of. The dream is Turiya, dreaming. The waking world is Turiya, waking. And the quantum multiverse is Turiya, branching the one awareness, endlessly differentiating into the many, without ever ceasing to be one. In Islam, the concept of the barzakh, the isthmus between two worlds, acquires its deepest significance in this context. The barzakh is not merely the realm that consciousness enters during sleep or after death. It is the nature of consciousness itself. Consciousness is always between the physical and the spiritual, between the manifest and the hidden, between one branch and another. It is never fully committed to any single realm, because it is not a thing that can be committed. It is the between itself, the interface, the boundary, the liminal space in which all realities meet. The dream is the most vivid experience of the barzakh because in the dream, the betweenness of consciousness becomes experiential rather than merely theoretical. You are between waking and sleeping, between memory and anticipation, between this world and other worlds that feel equally real. The dream is consciousness showing you its own nature, showing you that you are, and have always been, the space between. Ibn Arabi developed this concept into one of the most sophisticated metaphysical frameworks in the history of human thought. He described the barzakh as the realm of the creative imagination, the hadrat al-khayal, the level of reality where meaning takes form, and form reveals meaning. This is not imagination in the Western sense of making things up. It is imagination in the ontological sense, the power of consciousness to manifest realities that are genuinely real within their own domain. The dream, for Ibn Arabi, is not a subjective fantasy projected by the brain onto the screen of sleeping consciousness. It is a genuine perception of a genuine realm, the realm of images, the world of forms, the dimension in which the formless divine reality takes on specific, experienceable shapes. And this realm is not inferior to the physical world. It is intermediate, more real than the physical in some respects, less real in others, and essential for the full understanding of either. Ibn Arabi's concept of the creative imagination deserves further attention because it bridges the gap between the quantum framework and the contemplative experience more precisely than any other concept in any tradition. The creative imagination, al-khayal, is not a faculty of the individual mind. It is a dimension of reality. It is the level at which the formless becomes formed, at which abstract possibility takes on concrete shape, at which the infinite potentials of the divine nature crystallize into specific, experienceable realities. This is exactly what the quantum measurement process does. It takes the formless superposition of possibilities and crystallizes it into a specific, experienceable outcome. The creative imagination is the subjective experience of quantum measurement. The dream is the state in which this experience is most vivid, because the dreaming mind is not confined to a single measurement outcome. It is floating in the space of measurement itself, in the barzakh, between possibility and actuality, between the wave function and the branch, between the formless and the formed. Ibn Arabi writes that the creative imagination is the realm where contradictions coexist. A thing can be itself and its opposite simultaneously. A person can be in two places at once. Time can flow forward and backward. Space can expand and contract. These are not violations of logic within the creative imagination. They are features of a level of reality that is not constrained by the either-or logic that governs the actualized world. And they are precisely the features of quantum superposition, the level of reality in which a particle can be in two places at once, in which time reversal symmetry holds, in which contradictory outcomes coexist until measurement forces a resolution. The dream, as the experiential gateway to the creative imagination, is the state in which consciousness directly perceives the quantum superposition that waking consciousness, with its classical logic and its decoherence-imposed definiteness, cannot access. In Christianity, the theology of dreams connects to the broader theology of revelation and the nature of divine communication. The God of the Bible communicates through dreams, not because dreams are God's only option, but because the dream state opens a channel that waking consciousness normally keeps closed. The closing of the physical senses, the silencing of the rational ego, the dissolution of the critical prefrontal filter, all of these create the conditions for receiving information from a source that the waking mind's constant activity normally overwhelms. The dream is not a degraded form of communication. It is a specialized form, one that requires the temporary surrender of the faculties that normally dominate consciousness, so that the subtler signals of divine communication can be heard. The Christian mystic Jacob Boehme, writing in the 17th century, described the dream state as the moment when the soul returns to its original matrix, the divine ground from which it was emanated and to which it periodically returns during sleep. In this original matrix, the soul has access to knowledge that exceeds the knowledge available through the physical senses, knowledge of other souls, of other places, of other times, of the divine intention that underlies all of creation. Boehme's original matrix is, structurally, the universal wave function, the quantum ground from which all branches emerge and to which consciousness returns when the branching process is temporarily suspended during sleep. In the Aboriginal Australian tradition, The dream time is not a past era or a separate dimension. It is the continuous creative process that sustains the physical world at every moment. The dreamtime ancestors did not create the world and then leave. They are still creating it, still singing the world into existence, still dreaming the landscape, the animals, the laws of nature into their current forms. The physical world is the dreamtime's current dream, and when a human being dreams, they are briefly participating in this ongoing creative process, joining the ancestors in the dreaming of reality, contributing their own consciousness to the continuous act of creation that sustains the world. This is, in the quantum framework, a description of the participatory universe that John Archibald Wheeler envisioned. The universe is not a finished product that consciousness passively observes. It is an ongoing process that consciousness actively co-creates through the act of observation. Each quantum measurement is an act of creation, a moment in which the universe branches and a specific reality is actualized from among the possibilities. And dreaming, in the quantum timeline framework, is a state in which consciousness participates in this creative process with unusual freedom, unbound by the constraints of waking perception, unconfined to a single branch, touching multiple timelines simultaneously and contributing, through its observation, to the continuous creation of reality across the multiverse. The Aboriginal understanding may be the most radical of all, because it inverts the Western assumption about the relationship between dreaming and waking. In the Western framework, waking is primary and dreaming is secondary. Dreaming is something the brain does while the real business of life is suspended. In the Aboriginal framework, dreaming is primary and waking is secondary. The dream time is the source, and the waking world is its product. The physical world does not dream. The dream world's the physical. And when a human being enters the dream state, they are not retreating from reality. They are approaching the source of reality, the creative process from which everything that exists continuously emerges. This inversion is exactly what the quantum framework describes. The universal wave function, the totality of all branches, all possibilities, all timelines, is the primary reality. The specific branch that you experience as the waking world is a secondary reality, one actualization among infinitely many, selected by the measurement process from the ocean of quantum possibility. The dream, in which the decoherence barrier thins and the ocean of possibility becomes partially visible, is closer to the primary reality than waking is. The Aboriginal intuition is physically correct. The dream time is more fundamental than the waking world, and dreaming is a return to the source. We can now state the full synthesis. The brain during dreaming operates in a mode that is neurologically active, creatively productive, and perceptually precise. The quantum physics suggests that this mode may involve enhanced quantum coherence, resulting from the reduction of environmental decoherence when sensory input ceases during sleep. If consciousness is connected to quantum processes in the brain, as the Penrose-Hameroff model proposes, then the enhanced quantum coherence of sleep may allow consciousness to access information from neighboring branches of the quantum multiverse branches that are normally invisible due to decoherence, but that become briefly perceivable when the barrier thins. Dreams, in this framework, are not purely internal simulations. They are a mixture, partly simulation generated from stored memories and emotional processing, and partly perception, receiving information from the quantum landscape of branching timelines. The ratio varies. Most dreams are mostly simulation, but some dreams, under certain conditions of reduced internal noise, focused intention, enhanced quantum coherence, and practiced awareness, contain a significant perceptual component. The precognitive dreams, the seemingly telepathic dreams, the dreams that feel more real than waking life, these may be the dreams in which the perceptual component is strongest, the dreams in which consciousness has managed, briefly and imperfectly, to perceive the multiverse. The contemplative traditions have been cultivating this perceptual capacity for millennia. The Islamic practice of preparing the soul for true dreams through purification and intention. The Buddhist practice of milam, progressing from lucidity through transformation to multiplication to the recognition of ultimate reality. The Hindu identification of the dream state as a legitimate dimension of consciousness with its own realm of perception. The Christian understanding of dreams as a channel for divine communication that opens when the noise of the senses is silenced. The Aboriginal understanding of dreaming as participation in the ongoing creation of reality. Each tradition, in its own language and through its own methods, has been training consciousness to do what the quantum framework describes, to access the landscape of possibility that underlies the actualized world, to perceive the branches that waking consciousness cannot see, and to bring back information from those branches that enriches, deepens, and transforms the dreamer's understanding of reality. And here is where we must be honest about what we do not know. We do not know whether the many worlds interpretation is correct. It is one of several viable interpretations of quantum mechanics, and no experiment has yet definitively distinguished between them. If many worlds is wrong, the quantum timeline hypothesis collapses. We do not know whether quantum coherence in the brain persists long enough to affect conscious experience. The evidence from microtubule research is suggestive, but not conclusive. We do not know whether the decoherence barrier actually thins during sleep in a way that would permit quantum perception of neighboring branches. This has not been measured. We do not know whether the anomalous evidence, the precognitive dreams, the Maimonides experiments, the BEM data, reflects a genuine phenomenon or a systematic artifact of methodology, statistics, or publication bias. The replication record is mixed, and the mainstream scientific community remains skeptical. We do not know. And intellectual honesty requires us to say so plainly. But we also do not know that any of these possibilities are false. The many worlds interpretation has not been refuted. Quantum coherence in biological systems has been confirmed in multiple domains. The anomalous evidence has not been explained away. And the contemplative traditions, whose descriptions match the quantum framework with extraordinary precision, have not been shown to be merely cultural fantasies with no connection to reality. But here is what is remarkable. The fact that we do not know is itself significant. After more than a century of neuroscientific investigation, after decades of sleep laboratory research, after the development of brain imaging technologies that can decode dream content from neural activity in real time, after all of this, the fundamental nature of dreaming remains unexplained. We can describe the neural correlates of dreaming with extraordinary precision. We can identify the brain regions involved, the neurotransmitter systems engaged, the electrical signatures that distinguish dreaming from other states. But we cannot explain why the brain generates immersive virtual realities every night that the dreamer experiences as absolutely real. We cannot explain why evolution has preserved this energy-intensive, time-consuming, cognitively demanding process across hundreds of millions of years, and virtually every species with a cortex. And we cannot explain the anomalous evidence, the precognitive dreams, the telepathic experiments, the cross-cultural insistence that dreams are more than brain-generated fiction within the conventional materialist framework. The conventional framework is not wrong, it is incomplete. It explains some features of dreaming brilliantly: the memory consolidation, the emotional processing, the creative problem-solving. But it leaves the most fundamental questions unanswered: why dreams feel real, why they occasionally contain information the dreamer does not possess, and why every culture in human history has treated them as meaningful. The quantum timeline hypothesis does not replace the conventional framework. It extends it, adding a dimension that the conventional framework lacks, and that may be necessary to account for the full range of dream phenomena. What we can say is that the confident dismissal of dreams as meaningless neural noise is no longer tenable. The neuroscience alone has demolished this view. Dreams are meaningful, purposeful, neurologically precise, and cognitively productive. They solve problems, process emotions, generate creative insights, and construct immersive realities with a fidelity that rivals waking perception. Whatever else they may or may not be, they are not noise. And we can say that the question of whether dreams access information beyond the dreamer's stored memories and sensory history is a legitimate scientific question. The anomalous evidence is sufficient to warrant investigation, even if it is not sufficient to warrant belief. The quantum framework provides a physical mechanism that could, in principle, explain how such access might work. And the contemplative traditions provide millennia of systematic observation that is consistent with the hypothesis. The question is open. It deserves investigation, not dismissal. And we can say one more thing, the thing that every tradition, without exception, has said from the beginning. The dream matters, not as entertainment, not as a curiosity, not as neural housekeeping that can be safely ignored. The dream matters because it may be the one state of consciousness in which the filters that normally constrain your perception of reality are partially lifted, in which the blinders come off, the walls become transparent, and the full landscape of possibility, normally hidden behind the decoherence barrier of waking perception, becomes briefly, imperfectly, tantalizingly visible. Every night, you close your eyes and enter a world that your brain constructs with the same neural machinery it uses to construct waking reality. That world may be entirely internal, a simulation built from memories, emotions, and random activation. Or it may be partially external, a window into the quantum landscape of branching timelines, a glimpse of the multiverse, a contact with the dimension of reality that the waking mind's filters are designed to exclude. The Islamic tradition says the true dream is 1/46th part of prophethood. The Buddhist tradition says the dream is a bardo, a passage between worlds, a training ground for navigating the spaces between realities. The Hindu tradition says the dream state is a legitimate dimension of consciousness, as real as waking, revealing the subtle realm that the gross senses cannot perceive. The Christian tradition says God speaks in dreams when the noise of the day falls silent. The Aboriginal tradition says the dream time is more real than the waking world, and dreaming is participation in the ongoing creation of reality. And the physics says if the many worlds interpretation is correct, the branches are real, the decoherence barrier is finite, the brain's quantum processes operate at the boundary between one reality and the next, and the state of consciousness in which the barrier is thinnest, the state in which the brain is most active, most connected, and most free from the constraints of sensory input, is the dream. Tonight, when you close your eyes and the world dissolves and a new world takes its place, ask yourself, where am I? The answer may be more interesting than you think. You may not be in your bed, in your room, in your house, in your city, in your country, on your planet, in your universe. You may be at the crossroads of timelines, at the junction of possibilities, at the point where the branches of the quantum multiverse converge close enough to touch. You may be looking through a window that opens only when the waking mind releases its grip, a window into the probable timelines of quantum reality. A window through which, for a few minutes each night, the full landscape of what could be, what was, and what will be becomes visible to the only instrument capable of perceiving it, your consciousness, freed from its daytime constraints, wandering through the infinite garden of possibility that the multiverse has been growing since the first quantum event, 13.8 billion years ago, brought something out of nothing and began the branching that has never stopped. The traditions have been mapping this garden for millennia. The physics is beginning to describe its structure, and you visit it every night. The traditions say the garden has pathways. The physics says the pathways are branches. The neuroscience says the brain has the machinery to walk them. And the anomalous evidence, persistent, controversial, never fully explained and never fully replicated, whispers that some dreamers, in some moments, have found their way onto a path that leads beyond the garden of their own memories into the larger landscape of what is, what was, what will be, and what might have been. The question is not whether this landscape exists. If the many worlds interpretation is correct, it does. The question is not whether consciousness can perceive it. The contemplative traditions say it can, and the neuroscience cannot rule it out. The question is whether you will take the traditions seriously enough to practice what they teach, take the science seriously enough to test what it predicts, and take your own dreams seriously enough to pay attention to what they show you. Every night, the decoherence barrier thins. Every night, the quantum landscape becomes briefly visible. Every night, you are given a window into the probable timelines of reality. The only question is whether you will learn to open your eyes while you are there.